while constructing DFAs, we have been drawing transition diagrams. Okay, we have been drawing transition diagrams. So this thing, this is your Q0, this is your Q1, and then going from one state to another, representing it using an arrow, originating from one state, going to another state with arrow with a direction. This thing is called as transition diagram. Similarly, when you represent it using a table, it is called as transition table. So in a transition table, uh, what you do is you have a states mentioned, and here you have symbols. Okay, here you have symbols, and here you have states. So if your DFA has Q0 state, Q1 state, Q2 state, let's say Q3 state, let's take it at Q0, Q1, Q2. Okay, so if your DFA has Q0 state, Q1 state, Q2 state, and your symbols are 0 and 1, then you define it. Q0 on 0 goes to Q1, Q0 on 1 goes to, sorry, let's do it this way. Okay, let me remove it. Q0 on 0 goes to Q0, Q0 on 1 goes to Q1, Q1 on 0 goes to Q2, Q1 on 1 goes to Q0, Q1, Q2 on 1 goes to Q2. So this is the transition table for some DFA. So so what is the DFA? What would be the transition diagram? It would be like this: Q0. So Q0 on 0 goes to Q0. So you make it Q0, 0 goes to Q0. Q0 on 1 goes to Q1. According to the table, look at the table. Q0 on 1 goes to Q1. So Q0 on 1 goes to Q1. Q1 on 0 goes to Q2. So Q1 on 0 goes to Q2. Q1 on 1 goes to Q0. Q1 on 1 goes to Q0. Q2 on 0 goes to Q1. Q2 on 0 goes to Q1. Q2 on 1 stays at Q2. Q2 on 1 stays at Q2. If you look at the last video, if you have seen the last video, this DFA is what? What is this DFA? So L of M is omega such that integer value of omega is equal to 0 mod 3. If you make if you make Q0 as the final state, then if you make Q0 as the final state, then this DFA is this. Okay, if you make Q0 as the final state, then the language of the DFA is this. And how we got to this, we have seen this in the last video. So this is one of the thing that I want to. This is one of the, you can say this is one of the hint Okay, so next time whenever you are been asked the questions like L is equal to omega such that means summation is equal to 0 and 1, it means the strings would be a binary string. Then the integer value is 0 mod n. Let's say a question of this type. Okay, this is, let's say this is one type question, a typical question. No, not necessary. So any question of this type, how you can solve? If I am giving you a trick, sorry, how you can solve any question of this type, how you can solve, there is a trick for it. So you know that it's mod n, it means that the remainders would be from 0, 1, 2, so on, so on, n minus 1, and you know that for every such remainder you know you have states like, and you know that you have states like q0 which representing 0 mod n, q1 representing 1 mod n, and q2 representing 2 mod n, and so on. You will have qn minus 1 representing n minus 1 mod n. Okay, so this trick that I am telling you right now, it is strictly restricted to this type of language. Okay, this is special. This is trick for special type of languages. Means you will have a binary language. Means you will have a binary string, and you want to find the integer value in mod of something. Then how are you going to get the DFAs for it? The trick is simple. You have q0, q1, q2, q3, and so on, qn minus 1 going on, and you have 0 and 1 as a symbol. So what you're going to, how you should define the moves, how you should define the transitions is simple. Just go in a sequence. Just go 1 minute. Oh. Just go in a sequence like q0, q1, q2, q3, and so on, so on, so on, so on. q4, q5, q6, q7, and so on, so on. Similarly, at last you will end up in qn minus 1, qn minus 2. You will end up like this. That's what you have seen. If you want to cross verify, just look at this. There were 3 states: q0, q1, q2. How you defined? How you defined? So q0, q0. Okay, so these are the states: q0, q0, q1, q2. How you have defined the transitions? Just in a sequence: q0, q1, q2, q0, q1, q2. Okay, so this is one of the trick for this special type of problem. Like you have a binary string, and there is an integer value, and you have to determine 0 in terms of mod n. You have to classify it in terms of mod n. So for that, this is how you will give the transition diagram. Okay, so this is it. Now if the question is about not about 0 mod n, if it was about, let's say let's take this example only, integer value of w 0 mod 3. For this example only, if the question was not about 0 mod 3, if it was about 1 mod 3, then what you should do? Have the same transition diagram, just don't make in this, have the same transition diagram, make q0 non-final, make q1 as final. Similarly, if the question was about to accept the strings whose integer value is 2 mod 3, then make q2 as final state. Okay, then make q2 as final state. Very good. Thank you. I should end this right now.